Okay, I think we have completed this profile, right? I didn't remember actually. I think I think we have discussed this classification of channel bed slopes, that critical slope, mild slope, steep slope, horizontal slope, and adverse slope. I think these diagrams also we have discussed. Okay, this is for mild slope. When your slope is mild, when your bed slope is less than critical slope. Okay, so your critical depth line and your normal depth line. Okay, so your critical depth line will be lower than your normal depth line in mild slope. Okay, so the first one is your zone 1. Zone 2 is the zone between your normal depth line and critical depth line, and zone 3 is the lower part. Okay, so for steep slope also your SB is greater than SC, so your CDL will be more. Okay, CDL is higher than your NDL. Okay, and zone 1, 2, 3. Okay, for your critical slope, your CDL and NDL will be coincide. Okay, SB equal to SC. So your zone 2 is not there, because when these two lines is coincide, so there will be no zone in between the two line. Okay, so that is why we have only zone 1 and 3 in critical slope. Okay, okay, so we have discussed this thing now. Okay, okay, fine, no issue. Different methods. We solved numericals related to your gradually varied flow. Okay, so we are going to solve the first numerical. Okay, so you write down the equation 6.1. Just write down the equation. Over. So what is given? So it's given as a trapezoidal channel, bottom which is given 15 meter. Okay. Side slope is also given, one horizontal is to one vertical, and normal depth is given 1.5 meter. Okay. Slope is also given 1 into 10 to the power minus 4, and Manning's roughness is also given 0.02. Okay. So now that wire is constructed at downstream, rises the water level from 1.5 meter. Previously it was 1.5 meter. Now it's rise to the depth of 3 meter immediately upstream of the wire. Okay. So we need to find out the type of profile. Okay. So we'll move on to the solution. Okay. So first we need to find out the velocity. For finding velocity, we are using Manning's equation, as Manning's n is already known to us. Okay. It's given 0.02. Okay. So we are using Manning's equation to find out the velocity. Okay. So it's a trapezoidal channel. You find out the area. Okay. Normal depth is given 1.5 meter. That means the depth of flow is given 1.5 meter. Side slope is given 1 horizontal is to 1 vertical. That means Z is equal to 1. Okay. Okay. And calculate the velocity, because other terms are all are given. Base slope is also given 1 into 10 to the power minus 4. So you can directly find out the velocity. Velocity will be your 0.591 meter per second. Okay, after that we have to calculate discharge. Okay, so velocity we have calculated 0.591. Then we have to find out the discharge is equal to area into velocity. So area I think you have already calculated, and velocity you have just now calculated. It's 0.591, and you find out the discharge. Okay, so your discharge will be your 14.63 meter cube per second. After finding out the discharge, you have to calculate the fraud number. Okay, so fraud number is nothing but Vy root over Gd. Okay, D is nothing but area by top width. So you cannot directly use Y in place of D because here is a trapezoidal channel. Okay, in case of your rectangular channel, you can directly use Vy root over Gy. Okay, in place of D, you can directly write Y. But here in the question is given a trapezoidal channel, so you cannot write Y. Okay, so you have to find out the area divided by top width, and you find out the D value. Substitute here. Acceleration due to gravity we all know it's 9.81, and velocity we have already calculated, and find out the fraud number. How much you got? Fraud number? It's less than 1. So if you remember our specific energy curve, in x-axis we have specific energy, and in y-axis we have depth of flow y. Okay. Okay, so it will be at 45 degree, and for a particular discharge you'll be having one specific energy curve. Okay, so here this minimum specific energy, okay, this specific energy is minimum, E minimum. Okay, we have already discussed all this thing. This specific energy, this point is your E minimum, and corresponding to the depth of E minimum is your critical depth. Okay, YC. Okay, so if you draw a straight line, it divides the curve into two sections. One is in supercritical and one is in subcritical. Okay, subcritical. So if you remember, in supercritical your Froude number is greater than 1. Okay, and in subcritical your Froude number is less than 1. These things we have already discussed. Okay, so now see, and for critical depth YC, your Froude number is equal to 1. Okay, your Froude number is equal to 1. Fr is equal to 1 for critical depth. Okay, so for critical depth your Fr is equal to 1, Froude number is 1. For supercritical is greater than 1, and for subcritical it's less than 1. Okay, so now the value we got is less than 1. Okay, that means it's in subcritical. Okay, the short number value for this particular discharge we got less than 1, so that means our depth of flow is above critical depth. Okay, so for any depth in subcritical it's more than YC, that is your critical depth. Okay, or any value in supercritical it always less than YC, that is your critical depth. Okay, any depth in supercritical is less than your critical depth. Okay, and any depth in subcritical flow is your greater than critical depth. So definitely your whatever the depth here, if it is a supercritical, that means it's greater than your YC value. Okay, that means it will be greater than YC value. Okay, so this is will be your YN. Okay, so what they said, if this is in subcritical, that means your first depth is 3 meter, that is got rise. Okay, then YN value we already have, it's given 1.5 meter, but the critical depth is definitely less than your YN value because the flow is in subcritical. So we don't know the value of YC, but from here we can understand that our YN value is greater than YC value. What is the value of YC? We don't have. Okay, so just to identify that our YN value will be more than critical depth or less than critical depth, we have calculated Froude number. Okay, from Froude number we can easily can verify that our YN value will be more than YC value. Okay, so here we can write like this: 3 meter, because after constructing wire that our depth of flow at the upstream increases to 3 meter, so that 3 meter is greater than your YN, that is your 1.5 meter, and 1.5 meter will be greater than your YC value because they flow in subcritical. Okay, so now we have to identify the profile. Okay, so what it says, your YN value is 1.5 meter and YC value is not given. Okay, so when your YC is greater than YN, slope is mild. Okay, you see here, you can see here for mild slope, your SB is less than SC, your YN is greater than YC. You can see here. Okay, if your NDL, that is your normal depth line, is greater than YC, critical depth line. Okay, then your slope is mild. So now we have identified the slope is mild. Now, so this is your, like you can see in this diagram, for mild slope, this will be M1. Okay, it's printed wrong. Write M1. Okay, so our NDL is 1.5 meter. Okay, NDL is 1.5 meter. Critical depth line, we don't know the value, but it will be surely below the NDL value. Okay, and whatever the value we are getting after constructing the wire from the NDL, its got increases to 3 meter. Cost increases to 3 meter. Okay, so that is why our profile is your M1 profile. Okay, this is M1. Okay. So the solution of this question is M1 profile. Okay, so therefore profile is your M1 type. Okay, so this meeting will going to end very soon. So we'll start again. Okay, so you kindly join again. Hmm? And then we move on to the next numerical.